Student, today our lesson is about the 2.2. There's a linear motion graph. So I want to introduce some of the different graph. After that, the graph can be explained the motion of the object. Okay, let's see the linear motion graph. Okay, first one we're going to see the linear motion graph. What's the definition? Okay, that's one of the interpreting the graph. Okay, important to understand the type of the linear motion of the object. Okay, the motion of the graph is useful method. They want to summarizing the motion of the object. Okay, so from here we got three type of the motion graph. Later we need to know one by one. Okay, first one is a displacement time graph. That means the y-axis is the displacement. Then the x-axis should be the time. Okay, another one should be the velocity time graph. And the C should be the acceleration time graph. Okay, now we go and see one by one. Okay, now we separate by three types. We're going to see. Okay, this one is a three different of the graph. Okay, first one you're going to see the displacement time graph. This one is a VT. Okay, from here we cannot read about the acceleration. Okay, because you don't have any speed, so acceleration we still cannot read. Okay, for this one graph, actually what's the meaning? Okay, now you can see displacement is constant at certain displacement, but velocity is nothing. Velocity is nothing means the object is never moved. That means the object is stationary at certain displacement. So from here we can conclusion the object is rest. Okay, when I just mentioned the object rest, so you must think about VT graph is a zero, nothing. Okay, you can say about the zero velocity. So for the displacement graph, there's a constant graph at certain displacement. Then the AT graph we just ignore. Okay, now we go to improvement some more. Okay, now the displacement graph they start to increase. Okay, they start to increase means the object now got moved. From the zero, they move until certain meter. So from here, if the object got moved, that means we got velocity. Okay, now the velocity is a constant. Okay, constant reading. Okay, if you find the velocity is a constant reading, means when I find the acceleration, actually there's a zero. Okay, from here, what's the meaning for these three graphs? Object moving with uniform velocity. So uniform means constant, straight. Okay, we can using the word to explain the situation for the graph. Now we continue to see. Okay, displacement now they increase up already. This one we cannot say increase constant. This one we just can say about the increase. That means they move the displacement keep increasing. Okay, so from here you find here the velocity is no more constant. The velocity already is a pickup. Okay, compared to the displacement, because now you are increasing. So the velocity is an increase constant. So if you got velocity increase constant, mean now the situation already got acceleration. Okay, so from here the object is moving with uniform acceleration. Okay, now the gradient. Okay, we explain the gradient. Gradient ST graph. This one is a ST graph. This one the gradient actually is a velocity. So you find the gradient for every part that keep increasing, is it? So that means when I transfer to the VT graph, there's an increasing constant graph. Okay, now another one. There's a gradient of the VT graph. This one is a VT graph. If I find the gradient, they want constant number, is it? So everywhere you find the gradient for this straight line, there's a constant number. So this one constant number, there's a represent acceleration. So that's why you find the acceleration is a constant value. Okay, now we go another part. Keep increasing. Now displacement cannot read already because you keep increasing the velocity. Now velocity you can see they keep increasing. That means the gradient no more constant. The gradient keep increasing. So if the gradient keep increasing means acceleration now is a increasing. So from here I can say the object now is moving, increasing velocity. Okay, so you can see the acceleration, they are increasing constant. Okay, now we go another part. Okay, displacement time graph. Now you can see the graph is up after that drop. Okay, they curve already. Curve already means the displacement, they keep decreasing, decreasing, decreasing. So if I find the gradient from this one graph, I find it there's a negative. Okay, negative means the velocity now is a dropping. Okay, when starting is a high velocity, then drop until zero velocity. So this one situation, we call it the velocity decreases. Velocity decreases means slow down. Okay, slow down means if I find this gradient, sure is negative gradient. Negative gradient means deceleration. The object is moving in opposite direction of the acceleration. So that means when I draw the graph for acceleration, there is a constant value, but there's a negative. So I draw the line at the bottom. So from here, three graph here, I can explain by using one of the word, there's a deceleration. So that means when the question just asks about motion, you cannot say slow, you cannot say fast, you just can say velocity increase or decreases, or you say acceleration, or you say deceleration. Okay, so from here, for displacement time graph, the gradient is represent velocity. So another one is, for the velocity time graph, okay, for velocity time graph, we can find two things. Gradient represent acceleration. Okay, if I want to turn back to find displacement, I need to find area under the graph. Okay, understand? So from here, ST go VT, we find gradient. VT go AT, we find gradient. Okay, but you want to turn back. Okay, VT turn back to the ST, we find area under the graph. Okay, now we go to determine the distance, displacement, and also the velocity. Okay, we're going to see the situation. Okay, now they say the initial point and also the final point. Okay, initial point, the motorcycle, they start from here. Okay, they start to move to the right hand side, so we take the right hand side is a positive direction. Okay, after they move until 100 meter, they turn back. Okay, turn back means now it's a opposite direction. Okay, after turn back, they move in the negative direction until 50 meter away. Okay, so from here, this situation, we need to count about the distance, displacement, and also the velocity. Okay, now we go to refer the graph. Okay, now the situation is talking about the motorcycle. Okay, when starting A to B, the motorcycle go to the right hand side for 100 meter. Okay, after that, they come to the C. B to C, they stop a while. Okay, 5 to 8 seconds. The motorcycle will be rest at 100 meter. Okay, for 3 seconds. Okay, after that, from C to D means they come back. They turn opposite direction, go back to the original point. There's a point A. Say, so they take how long? They take 4 seconds to turn back. Okay, D to E, what happened? D to E is a rest. Okay, they don't have any movement. Okay, until D to E. So from here, they take how long? They take 2 seconds. Okay, now E to F, they move 14 until 20. This one's a 6 seconds. They move in opposite direction for negative 50. Okay, that means they turn back. Okay, now we need to part by part to explain the motion of the motorcycle. Okay, let's see the first one. Okay, first one, they say the motorcycle is ridden from the distance 100 meter to the right for 5 seconds. Okay, gradient. Okay, we need to find the velocity is how many? So 100 minus 0. So we take 100 minus the 0 over 5. So we know A to B, the velocity is a 20 ms negative 1. So from here we can explain velocity of motorcycle is 20 meter per second to the right hand side. Okay, so this one is a section AB. I go to explain the motion. Okay, now I need to explain about the BC motion. Okay, B to C, the motorcycle is stop. Okay, stop, 3 seconds. Okay, so now we go to find the gradient. Gradient sure is a 0 because they don't have any velocity. So from here I can say the velocity for the motorcycle now is a 0. Okay, then we continue to B to C to D. Okay, section CD, motorcycle is ridden back to initial point A. That means the reverse go back to the original point. Okay, taken 4 seconds. So if I find the gradient, so from here the gradient sure is a negative. Okay, this one negative actually what's the meaning? This one negative means patah balik. They turn back, reverse back. So this one I put negative. So from here I can explain, therefore the velocity motorcycle now is 25. Okay, but I add one more word, left. Okay, I ignore the negative, so I just say the negative actually there's a represent the direction. So that means now the motorcycle then move to the left hand side with the velocity 25 meter per second. Okay, then the last part I need to explain about the DE and also EF. Okay, let's see that. Okay, now D to E motorcycle is stationary again, but now there's a stationary at the initial point. Okay, starting point for 2 seconds. So that means rest means no velocity. So from here velocity motorcycle is 0. Okay, how about the E to F? Okay, E to F, the motorcycle is ridden to the left already. Okay, so E to F means totally is the opposite direction. Okay, now they go to the left hand side for 50 meter. Okay, in 6 seconds. So this one negative means there's in opposite direction. So gradient we still can find. The gradient is a negative 50 over 20 minus 14. So we get it, the answer is a negative. Negative means opposite direction. 8.33 ms negative 1. So from here I can say the motorcycle velocity now is a 8.33 but go to the left. Okay, so from here we cannot find it, the motorcycle is slow down. We just can find it, negative means the motorcycle move in opposite direction. Okay, so this one is a displacement time graph. Remember, you want to find velocity, you need to find gradient. Okay, now after we find the velocity, now we need to find out average speed and also the average velocity. So what's the difference? Speed is a scalar quantity, velocity is a vector quantity. So that means one we need to using distance, another one we need to using is a displacement. Okay, let's see the calculation. Okay, distance travel is how long? When starting is 100, then stationary, then come back also is 100, then stationary, then go to the left hand side is a 50. So if distance is nothing, we no need to count about direction, is it? We just plus. So 100 plus 50 become 250 meter. Okay, if I say I want to count displacement, so you need to care about the positive and negative. So when starting go to right is a positive. Okay, now you go to left, you turn back to the original, go until D, there's a nothing. Because 100 plus minus 100, there's a nothing already. So start from E to F, you move in left hand side. So that one should be the negative 50 meter. Okay, so this one I want to separate the distance and displacement because they are easier for me to calculate the average speed and also the velocity. Okay, now we show the formula. Okay, distance travel is a 250. Time taken is overall is 20 seconds. So we just take 250 over 20. The answer is a 12.5 meter per second. So this one is the average speed. Okay, how about the average velocity? Okay, overall the displacement is a negative 50 meter, is it? So in the total time taken also 20 seconds. So therefore, the average velocity, we just take negative 50 over 20. So from here, my answer sure got negative. So negative 2.5 ms, negative 1. So this one, the negative means the motorcycle now is moving in the opposite direction. Okay, so now if we finish about the displacement time graph, now we do one of the example question. Okay, this one is a VT graph for an object, the linear motion. We need to determine the velocity of the object for every stage. So from here, they need to find out gradient. Is it they want to find velocity? So we separate by the 3 parts. Okay, first part is from the 0 to 6 seconds. Then after that, 6 to the 12. Then 12 to the 20. So from here, we part by part go to solve it. Okay, first one 0 to 6. So we need to find the gradient, is it? So the gradient is a 6 minus 0. Then another one is a x 6 also minus 0. So the first one we find it, the velocity is a 1 ms negative 1. Okay, how about the part B? So we call it, this one is a part B lah. From the 6 go to the 12 second. So part B, actually there's a flat, is it? Flat, that means the object now is stationary. Okay, they never move, they just rest. So if stationary, the velocity, it will become the 0. So, but I still need to show about the calculation. Okay, so 6 to the 12, 6 minus 6, because there's a flat. Okay, then the bottom one sure is a 12 minus 6. So they become 0, because this one already is a 0. 0 over anything also is a 0. So your answer is a 0 ms negative 1. Okay, now we go to the last part. Okay, the last part, can you see the graph still up? So this one graph still positive. Okay, still continue to the right hand side. So we still need to find the gradient. Okay, the gradient 12 until 20. So there's a from 10 minus 6. Then over the x-axis, 20 minus 12. So from here I find it. Now the object still moving with the velocity 0.5 ms negative 1. So you can see all here is a positive, means the object still keep moving to the right hand side. Okay, so this one is how we go to find the velocity of the motion object for the every stage. Okay, so from here we continue just now question. This one is a result we find just now. Now I need to interpret the displacement time graph to become VT graph. So from here we find first round 0 to 6 seconds, 0 to 6 seconds, they're moving 1 ms negative 1. So that means I lock here. So from here I go to show how to draw. Okay, I draw the horizontal line. There's a 1 from 0 until 6. Okay, now we go to second part. 6 to the 12, there's a 0 ms negative 1. So that means from here lah, 6 to the 12. Suppose there's a exactly at the y-axis because you are 0. So I need to draw. Okay, I need to draw the flat line. Okay, 6 until 12. Okay, from the 12 to 20, they're up again until 0.5, is it? So I need to draw the line. Okay, from the 12 to 20, there's a 0.5 velocity. So I just draw the flat line. After that, you need to join the dotted line. So we can see very clear where's the location of the velocity. So this one we call from the displacement time graph, convert to the VT graph. Okay, now we determine the distance, displacement, velocity. We add one more, acceleration. So that means this one is the initial point. Okay, the bicycle, they start to move to the right hand side, positive direction. Okay, after they move, they will turn back. Okay, they move, after that they reverse, come back until here there's a final point. Okay, now we refer the graph. So that means when starting 0 to 50, okay, see here, this one is a VT graph. Okay, not displacement time graph, this one is a velocity, means the object got moving. Okay, the object moving constant velocity 10 for 50 seconds. Okay, after that they start to accelerate. Accelerate until 15. Okay, using how long? 20 seconds. Okay, after that until 15 they accelerate. Okay, now they start to slow down. Okay, slow down means deceleration. From the 15, drop until 0. Okay, let me slow down until 0 using 30 seconds. So until 100 to 120, now the object is rest. Okay, they never move. Okay, after that, after 120 seconds, now the object, they start to move again, but in opposite direction. So that means maybe this situation they start. Okay, this situation is 120. So from here they turn back. Okay, reverse the direction, move until 150 seconds. So this one direction they move until negative 9 velocity. Okay, for this hole, when you just turn back, this one we take 9 velocity, then the time taken is 30 seconds. So we need to explain part by part. Okay, L1 until L4. So we go through. Okay, 0 to 50 means the L1. Gradient is a 0. Okay, the gradient is represent acceleration, is it? So therefore, the bicycle moving to the right with uniform velocity, there's a tap. Okay, you also can say they're moving to the right with 0 acceleration. Okay, now we from the 50 goes 70. Okay, 50 to 70, you find it, the graph is up, is it? Up means got accelerate. So from here, I need to find the gradient. Gradient is a 15 minus 10, 70 minus 50, so I get 0.25. So this one is the acceleration. So from here, I can say the bicycle now moving to the right with uniform acceleration. How many? 0.25 ms negative 2. So I explain the motion of bicycle by using acceleration. Okay, now we drop. From the 15, we drop until 0. So this one situation sure is slow down. So I still need to find deceleration is how many. Okay, now we time interval 70 to 100. So I find the gradient 0 minus 15, 100 minus 70. Okay, so from here I get it negative 0.5. Okay, negative 0.5, this one situation is slow down. So I need to explain. Acceleration of the bicycle now is a negative. So the velocity of the bicycle gradually decreases. Okay, they slow down, the move becomes slow. So the bicycle acceleration at negative 0.5 ms negative 2 in the opposite direction of the motion of the bicycle. So that means they slow down. Actually, you go to right hand side, is it? You slow down means you want to opposite the direction of the motion. So that's why you get negative. Okay, we also can say that there's a deceleration. Okay, 100 to 120, the gradient is a 0, means velocity also 0. So therefore, the bicycle has stopped. Okay, the rest for 20 seconds. Okay, after 20 seconds, that means the last one, the L4, time interval 120 to 150. Now we need to find the gradient. The gradient is a negative 9 over 30. So we get it, the answer still negative 0.3. Okay, but this one situation is acceleration of the bicycle. Okay, L4 we cannot say slow down. L4 already is a accelerate. Okay, we ignore the negative. Negative means they move opposite direction. So from here we can say acceleration of the bicycle is a negative 0.3. So from here the velocity of the bicycle is gradually increases. Okay, L3 is a gradually decreases. Okay, but L4 is a gradually increases. The bicycle accelerate at 0.3 in the same direction as the motion of the bicycle. So that means the direction is the motion, not the direction of the bicycle to move. Okay, just now you get negative, they say in the opposite direction of the motion. Okay, the motion is keep to right hand side, is it? When you slow down, that means you are opposite. So from here, the L4 part, I'm the negative means I turn opposite direction, but the direction of the motion still positive because you keep increasing the velocity. Okay, so this one is an explanation. When you see the VT graph, the line below the graph, we know that one is a opposite direction. So from here, we're going to find area. Okay, if the question they want to find area, so L1 should be the area under the graph. That one is a displacement, is it? So from here, we're going to find the distance and displacement. So L1 we get 500 meter. So L2 is a trapezium. So you're using trapezium, the formula. L2 we get it 250. L3 is a triangle, 225. L4 also is a triangle, there's a 135. So if overall distance is how many? Overall distance we just plus. Because distance we don't care about direction. So we plus all the L until L4. So I get 1110 meter. Okay, so this one is how we get the distance. Okay, now another one is a displacement. Displacement means you plus L1, L2, L3, but you go to minus L4 because L4 is left hand side. So from here I get it 975. Okay, L4 is 135, so I need to minus. So overall, total displacement is 840 meter, but go to the right hand side. Okay, because the right hand side is still bigger. Bigger minus the smaller, so we still continue positive. They go to the right hand side. Okay, now we need to determine the average speed and also the average velocity. So average speed, that means we're using distance. Okay, so distance just now we find 1110. So we do the calculation 100, 1000, and also the 10 over overall time 150. So from here I get the answer is a 7.4 meter per second. Okay, how about the velocity? Okay, velocity means you need to take the displacement. Total displacement, there's a 840. Time taken is the same, 150. So from here we get it, the answer is a 5.6 ms negative 1. Okay, normally the velocity be shorter than the speed because displacement shorter than the distance. Okay, now we're going to try VT graph. This was an example 2. Okay, they plot the linear motion car driven by the inject Kasim. They drive his car at the speed 30. Okay, when starting is a 30. After that, they apply the brake when they see the obstruction on the road. Now they interpret the VT graph. Okay, you need to sketch this one VT graph. Later convert become displacement, and also you need to convert become acceleration. So if you convert displacement, that means we need to find area under the graph. Okay, let's see here. Displacement equal area under the graph. So we need to separate by two parts. Okay, first part is from the 0 to 6. Another one is a 6 to the 10. We need to find the area. Okay, so we find the first one, the rectangle, is it? Okay, rectangular first. Okay, area, this one is a rectangular. So we just take 30 multiply 6. So I get it 180 meter. Okay, now we continue 6 to 10. There's a triangle. Okay, so the triangle is 30 multiply with the 4 divided by 2. Okay, divided by 2, so it's a 60 meter. Okay, so I separate part by part. Now I go to draw the graph, displacement time graph. Okay, so from here the displacement time graph, total displacement is a 240 meter. Okay, for the 10 seconds. So from here I need to show the graph. Okay, so we start with the 0 to 6. Okay, 0 to 6 I get 180, the first one. So I draw straight line. Okay, because this one straight line 0 to the 6. If you find gradient, the answer should be 30. Okay, so from here until here I stop. Okay, now the part B. Because part B you are slow down, is it? Slow down, the graph should be curved. Okay, should be curved. So from here I need to know overall. Overall is a 240 meter. So from here 180 continue to move until 240. So I mark the point here. Okay, there's a 6 until 10. So from here you need to start to draw the curve. You cannot draw straight because we know this part is a slow down. So that means you need to draw the curve until you touch the 240 meter. So this one we call it displacement time graph, convert by the VT graph. Okay, so we label this one is a part A, this one is a part B lah. Okay, the triangle part there's a here. Okay, now AT graph. Okay, AT graph means the gradient, is it? So from here we need to show. Okay, 0 to 6. Okay, just now the graph 0 to 6. There's a 30 over 30. 30 minus 30 because there's a constant, is it? So we get it, there's a 0. Okay, another one 6 to the 10. Just now there's a triangle, is it? So we find it 30 minus 0, 6 minus 10. We get it, there's a negative answer because you are dropping. Okay, we get it 7.5 negative. So when I just want to convert to the acceleration time graph, so when starting 0 to the 6, there's a 0 acceleration. 6 to the 10, we find it negative 7.5. So I need to draw negative 7.5. Okay, This one, the situation means the object now is moving in opposite direction of the motion of the object, means slow down. Okay. Okay, then we continue with this part. There's a one example question, VT graph. They want you to determine the acceleration, displacement, and also average velocity. So acceleration means we find the gradient. So from here, I need to show first acceleration equal gradient of the graph. So from here, we separate by three parts. Three parts to find the gradient. Okay, so from here, the first, 0 to 3, gradient is a 6/3. So there's a 2 ms negative 2. This one is the acceleration. Okay, 3 to 6. 3 to 6, we don't have any gradient because there's a flat. So the answer for acceleration, there's a 0. Okay, then 6 to 10. So this one velocity drop. So mean this one is a deceleration. Your answer sure got negative. So from here, 6 minus 10, 6 minus 0, 6 minus 10. So I get negative 1.5. Okay, so for the 6 until 10, this part should be the opposite direction. Sorry, not opposite direction. This one is slow down. Okay, if I continue to draw below the graph, that one is opposite. Okay. Okay, now after the A, now I need to find displacement. Displacement means area under the graph. So I need to explain first. Displacement means area under the graph. So I also separate by three parts. Okay, if you don't want to separate by three parts, you can straightforward to say this one is a trapezium. So from here, I can say displacement equal area of the trapezium. Okay, so the trapezium using the formula is half. Then A plus B, is it? The A is how long? A is a 10 second. Okay, B is this part. 6 minus 3, there's a 3. Okay, A plus B multiply the height. The height is a 6. So after that, I get it 39 meter. Okay, so from this one graph, I find the area under the graph. There's a displacement. There's a 39 meter. Okay, so the last one sure is the average velocity lah. So average velocity, just now we get the displacement is 39, is it? So we straightforward take 39 over 10. So the answer is 3.9 ms negative 1. So this one is the average velocity. Okay, now we got example number 2. VT graph. Okay, for the motion, interpret VT to the displacement and also acceleration. That means now you need to draw the graph. Okay, first one we want to change become displacement graph. Mean you need to find area first. Okay, we step by step to find area because here got three parts. Okay, displacement equal area under the graph. Okay, so from here we need to show the first one. That's a part A. Okay, we find the area first. So the part A, the area is a 10 multiplied 10. That's a 100 meter. Okay, so the part B is a trapezium. So the trapezium, so we show the trapezium half A plus B. Okay, A is a 10, B is a 16. B is the length should be the 30 minus 10. So there's 20. So we get it. B, part B, the displacement is a 260 meter. Okay, now we go to part C, triangle. So the triangle is a half multiplied is a height and also the width. So I get it, the answer is a 160 meter. Okay, so from here, this one is a one part by one part, the displacement. Okay, now I need to overall. Okay, 100, 260, 160. Okay, so that means the displacement after 30 seconds is how many? Okay, after 30 seconds means 100 plus 260, there's a 360 meter. So if I say after 50 seconds, total displacement is how many? 520 meter. Okay, for this overall, they're still same direction. Okay, they never move in opposite. Okay, now I need to plot the graph for the displacement time graph. Okay, let's see here. Okay, when starting, there's 100. Okay, 100 is a constant, means straight line. Okay, constant velocity means straight line. 10 to 100. Okay, until this part. Okay, this part already is a still straight line. I cannot say straight line already because this one already velocity increase. So that means your displacement must be up and also curve up. Okay, curve up, not curve down. So from here, total displacement how many? 360, is it? So that means from 10 to 30. So until 360. So that means you start from 100, you need to curve up until 360. Okay, now we go to last part. Last part, drop. Drop means your graph now is a curve drop. Okay, curve drop how many? Until 520. Okay, so that means from the 360, you need to draw the curve until 520. Then there's a 50-second, then we finish. So that means displacement graph also separate by 3 parts. Part A, part B, and also the part C. Okay, we go to focus. First one is 100. Then the second one is a 360. And the last one should be 520. We keep increasing the velocity. Okay, after sketching the displacement, now we need to sketching about acceleration time graph. So this one, acceleration is a gradient of the graph. So that means we need to find the gradient for A, B, and also the C lah, if you want to plot the graph. Okay, so from here, we do the calculation again. 0 to 10, so that means 10 minus 10 over 10, so should be 0. Because here is a flat. Flat is don't have any acceleration. Okay, 10 to 30 now got accelerate already. The velocity increase. So that means 16 minus 10, 30 minus 10. So I get it 0.3 for the part B. Okay, part C, the acceleration shows negative because you are slowed down. So from here, I get the gradient is a negative 0.8. Okay, so now I need to convert, okay, this all reading to the AT graph. Okay, let's see the AT graph. When starting, there's a 0. So 0, we just draw the 0 lah. Okay, another one should be 0.3 positive. So I draw 0.3 from 10 to 30. Okay, 30 to 50, there's a negative 0.8. So I come down. 30 to 50, I point 0.8. Okay, then the last one, you draw the straight line. So this one is an acceleration time graph. Okay, convert by the VT graph. Okay, so this one is an explanation for the motion of the graph, how we convert. Okay, so from here, hopefully you understand. So today task, what you need to do, you need to finish the formative practice. There's a 2.2. Please do inside your exercise book with the school logo one. The exercise book green color. Okay, so from here, this one more thing to show. Okay, this one is my channel. So if you want more video about the physics, that means you can refer my channel. Okay, today code. Okay, I need to give the class code, is it? Before you want to attend, to write your Google form for attendance today. So the code should be hashtag. Okay, you write hashtag. After that, you help me to write motion. M-O-T-I-O-N, capital letter. Okay, just like this only. Hashtag, then motion, M-O-T-I-O-N, capital letter. No spacing. Okay, so that one is a today code. So hopefully you listen, so later you can attend to write your attendance for today's. Okay, so our lesson just until here only. So hopefully you understand, and also you can complete today the task. Okay, just thank you for your watching. Bye.